Number 14. If a gas occupies 500 milliliters at 25 degrees Celsius and 13.2 psi, find the new temperature in degrees Celsius when it occupies 1.3 liters and is under 105 kPa of pressure. I see two pressures, I see two volumes, and additionally, we're talking about one temperature and looking for another temperature. Problem like this, two pressures, two volumes, two temperatures, we are doing P1 V1 over T1 equals P2 V2 over T2. However, there's a few issues here that we have to resolve before we plug any numbers into the equation. Pressure needs to be in the same units on both sides of the equation. Similarly, volume can be in any units as long as they match, but temperature, absolutely, when I solve it, has to be in Kelvin. So if I'm looking at what I'm given, P1 is 13.2 psi. V1, 500 milliliters. T1, 25 degrees Celsius. P2, 105 kPa. V2, 1.3 liters. And T2 is what I'm looking for. So in terms of units that need to be resolved here, I need this pressure and this pressure in the same units. I'm going to convert PSI to kPa. I know that 101.3 kPa is equivalent to 14.7 psi. I get that number from my formula sheet, or those two numbers from my formula sheet. Therefore, 13.2 psi is equivalent to how many kPa? Solving this proportion, 101.3 times 13.2 divided by 14.7 gives me 90.96 kPa. All right, I also need, now I have these in the same, I also need to put volume in the same units. I'm going to turn this one into liters. Temperature needs to be in Kelvin. I'm going to add 273 to 25 degrees Celsius, giving me 298 Kelvin. Now I'm ready to plug in. P1, 90.96. V1 is 0.5. T1, 298. P2, V2, and my unknown T2. I'm going to cross multiply and then divide. So in my calculator, 105 times 1.3 times 298 divided by 90.96 and divided by 0.5 also gives me T2 to be 894 Kelvin. We were asked to find the temperature in degrees Celsius. Though I solve it in Kelvin, I convert afterwards by subtracting off 273, giving me 621 degrees Celsius as an answer.